Good day. In the previous video, the sequence there is defined as a set of numbers. Now, in this lecture, I'm going to define the sequence using the concepts of functions. So we have here the definition of the sequence. It is a function f from n, from the set of real numbers to the set of, from the set of natural numbers to the set of real numbers, which is defined by f of n, which is equal to u sub n for all natural number n. So we have here the illustration for the sequence as a function. So notice here the set of natural number is our domain. So every natural number is assigned to a unique term in the sequence. Say we have 1, the range is, or the image is f of 1, which is equal to u sub 1, where u sub 1 here is the first term in the sequence. Then we have here a natural number 2, and the image of that is f of 2, which is equal to the second term of the sequence, which is u sub 2, and so on. Now, how to determine whether the sequence is bounded or not? So this is very simple here, because to determine if the sequence is bounded or not, we will just look into the range of the function. Now, if the range here is bounded, we say that the sequence is bounded. Otherwise, the sequence is not bounded. Now, let's try to have here an example. By the way, let's have here first the notation. For our notation of the sequence as a function, we use this notation where u sub i's are the images of the element of the natural number under the function or sequence, and then u sub j here is the jth term of the sequence. So we have here u sub n. This is the jth term of the sequence. Say u sub 2, it means second term of the sequence. Then the range here is the set of all terms in the sequence. Now let's try to have an example here. Let's try to consider this sequence. We have 1, 3, 5, and so on. So the range of the sequence is this set, this one, with elements 1, 3, 5, and so on. As you can see, the set here is infinite. Therefore, this sequence is not bounded. Okay, let's have another example. Let's have this sequence here. Okay, so defined by the formula S of n, which is equal to negative 1 raised to n. So here, of course, S sub n is negative 1 if n is odd, and then positive 1 if n is even. So let's try to have an illustration, using the real number line. So as you can see, the elements in the term in the sequence, or the terms in the sequence, are only negative 1 and 1, but there are infinitely many of them. Like for example, the first term is negative 1, so here is the term of the sequence. So first term, we have u sub 1, that is negative 1. And then when n is, say n equals 1, when n is 2, u sub 2 is positive 1 because 2 is even. So we have here the point here, when n is 3, u sub 3, because 3 is odd, we have negative 1. So another point here, when n is 4, u sub 4 is equal to this even, positive 1. So we have another point here, and so on. So the terms in the sequence are only negative 1 and 1. So take note, there are infinite number of terms here, -1. There are infinite number of terms here, 1. But let's try to look at the range of the sequence. Okay, the range of the sequence are only -1 and 1. Now, as you can see, this set is finite, or it is bounded sequence, it is bounded set rather. So if the range is finite, we mean that the sequence is bounded. Okay, it is bounded. Or if we will try to use the concept in our previous video, that if the sequence is bounded, it is bounded above and bounded below. Now, as you can see in our sequence here, since the terms are only -1 and 1, you can see the sequence is bounded above because we have upper bounds, and then it is bounded below because we have here the lower bounds of the sequence. So that's it. You can say that the sequence is bounded.